I thought that should exist some kind of mechanism which will allow us to somehow modify the aging process and make it even reversible. So then nature builds something, a biological object, let's say. It always leaves some kind of key or clue how to rebuild in case of, if it's necessary, so you can rebuild it whatever already was built. So, but these keys unfortunately are hidden. Hidden keys for regeneration and rejuvenation even are hidden by nature, but they exist. So the problem was how to find them, those key mechanisms which allow us to regress into the past. It's some kind of like biological time machine, which sounds very unreal thing, but basically it exists. Reversible biological processes, they exist in nature, and as a good example, first who actually discovered this phenomenon of reprogramming of human somatic cells was Professor John Gordon of United Kingdom. In 1968, he conducted very interesting studies when he combined in one petri dish, he combined human keratinocytes epithelial cells, skin cells, with extract which was made from Xenopus laevis oocytes, these South African frogs. As a result of this co-culture, out of 100,000 cells, several cells were converted into embryonic stem cells. So originally they thought that it's like some kind of artifact in those studies, and what's the practical use if out of 100,000 cells you can get only 2, 3, 5 cells which were regressed. Because for therapeutic application of stem cells, we need at least 100,000 to 1 million cells to inject into the patient so they can have some kind of therapeutic effect. On the other hand, I understood that stem cells are very dangerous biological objects, because the stem cells have a manual how to build the entire body, like yours and my body. And also was shocking the speed, the dramatic speed, I would say relativistic speeds with which, let's say, human embryo develops. During 9 months, speed is 20,000 cells per second. Everything orchestrated very precisely. And our molecule, many biological molecules, they are just rotating around axis. For example, phosphodiesterase molecule rotates with 20,000 revolutions per second. And with each revolution, it converts cyclic GMP into cyclic GMP. This is a component without which you cannot even participate in visual visual process. So we were squeezed, like from one side.